Hello everyone, and thank you for joining our webinar this afternoon. My name is Jeremy Schmid and I'm joined by Andrew Linsack. He's a senior application consultant here at eBECS, and he's going to be taking you through demand forecasting in AX 2012. I'm really excited about this topic because as part of the R3 release, demand forecasting is a brand new piece of functionality. And not only now are you able to deploy a forecast in AX, but we're actually able to use this functionality to create that forecast. And that's something we've been missing in previous versions of AX. So we're really excited about this content and really looking forward to Andrew taking us through it this afternoon. Before I hand it over to Andrew, just a quick overview of eBECS. We are a total Microsoft business solution, and we deliver those solutions globally. So just to touch on a few, we obviously have high expertise in AX, CRM, BI, as well as Azure. A few awards I just want to point out that we've won. In 2013, we were named the Global Partner of the Year. And in 2015, we were named to the Inner Circle for Microsoft Dynamics. And we've actually won that award 5 years running, and it's only given to the top 5% of Microsoft partners. So we're pretty proud about that one. Okay, so that's enough about eBECS, and now I'm going to hand it over to Andrew, who's going to take you through the rest of the presentation and demand forecasting. Again, thank you for joining.
So first off, in the introduction of myself, I've been in the AX world probably about 8 years now. First as an end user for a large manufacturing company that was worldwide. Then as a business analyst, my focus mainly was on production, master planning, and inventory before becoming a functional consultant. So I worked with a couple other partners before coming to eBECS a little over a year ago, mainly focusing lately on warehouse management, master planning, including demand forecasting and production. As Charlotte mentioned, today's main focus is to talk about demand forecasting in R3. Now, this is something you'll hear a lot about when it comes to the newer version of AX 7, but it was introduced here in AX 2012 R3, and that's what we'll be demoing today. We'll start off with an introduction of what AX demand forecasting is, compare it mainly to what you might think of as forecasting in traditional or earlier versions of AX. The importance of item allocation keys and how they relate to AX demand forecasting, the various parameters and forecast algorithms that are available, outlier removal, so that's specific transactions that you want to exclude from forecasts, how you generate and analyze the forecast, publishing and importing that forecast, because we're going to talk today a lot about cubes and Excel, and then as well as generating forecast KPIs and forecast accuracy KPIs. Now, if there's any questions at any point, feel free to type them in to the GoToMeeting, and we'll come back to them afterwards. During the presentation, we'll leave the attendees on mute just so we can make sure we get through all the information, and then we'll leave time at the end to come back for questions. So the basics. There's a couple things not on this slide. One, demand forecasting, it is very new. If you've used AX before, whether it be a former version or it's 2012 prior to R3, you'll know that master planning was able to use forecasts to generate master planned orders, but it never had the ability to analyze history and come up with those forecast figures. Typically, you were doing that in your own Excel-based tool or some sort of add-on to actually come up with those forecast quantities, and then you were just applying them to master planning. Here in 2012 R3, it's basically built into the master planning module where you're able to read history in AX and come up with those figures and analyze them or change them as necessary. So it's a tool to help you conduct your forecasting process that wasn't available before. It's designed in a way that can be easily extended. So what we mean by that is basically there's room open to customization. It is kind of Microsoft's first attempt at this. And we know there are some best-of-breed forecasting packages out there that have more functionality, and this leaves us open to get there in the future. Right now, there are some limitations, or should I say some options that are fairly limited. So the main example of this is there's really 3 models, forecasting models, that Dynamics AX has in other package packages. You might have many models, linear regression models, different Box-Jenkins methods if you're familiar with statistical forecasting. Here in AX 2012 we have three. We have what's called ART-XP, which is auto-regressive tree cross prediction, if I remember that correctly. Long name, not something you really need to remember. This is something Microsoft developed after lots of research. It's mainly used for short-term prediction, so it's not usable in a lot of environments. It's resistant to deviations in the short term, but anytime you get past a couple days, a couple weeks, next months, etc., you really want to switch to ARIMA, which is a standard forecast model that's used in other packages. It's a Box-Jenkins forecasting method if you are familiar with them. Not good for the short term, but really good for long term. So if you're forecasting in monthly buckets, a year out, 2 years out, etc., you would probably want the ARIMA method, and that's the one we'll be demoing mostly today. And then there's also a mixed model, which tries to kind of handle the best aspects of both worlds and smooth your predictions over the short and long term. I'll try not to get too technical today. It's going to be fairly high level, so hopefully that's as technical as I get when I talk about autoregressive tree cross prediction and things like that. We're mainly going to try to get into the demo. You'll see a lot of information on these slides, and I'll try to get through it as best I can. The generation of the baseline forecast is based on historical data, and it's expressed in quantity only. So what I mean by that is you might have many items all sold in different units, and we're going to end up forecasting all of those. Well, eventually you're going to realize that you can't group a bunch of items that have different units of measure together. So this works off of a standard unit of measure. Typically you would set up like eaches, and then when it's re-imported, it would recognize exactly what those units of measure are for the items, because the way, what you'll see how this all works when we get into the item allocation keys is you're grouping like items together. So like items meaning historical trends, not necessarily what their unit of measure are. And to be able to actually generate a forecast for multiple items that all have different units of measure, you kind of have to use this conversion into a standard forecast quantity or unit of measure. So we set that up in the parameters, and then, like I said, when we re-import things or the forecast generation is run, it would convert those back into their units of measure in the forecast tables later on. What this gives us the ability to do is visualize demand trends and adjust the demand forecast. So a little bit of an overview how all this is done in AX. I'll give you a graph. It's basically grabbing data from AX, from the tables in the background, pushing those out to the SQL Server cube. So there's a specific cube just for demand forecasting, generating a statistical forecast based on that demand as well as the parameters you have set up in AX. It then allows you to view that in Excel, create pivot charts if you need to, create KPIs if you need to, using standard Excel tools. You can make changes to that forecast. You could basically throw out that copy of Excel, go back in, make parameters, run the forecast again, and start over. Once you're happy and you agree with the forecast and want to bring that back into Excel, you publish that to the SQL Server cube and then import it back into AX. So when you import it back into AX, you're actually overriding the tables that the forecast currently lives in. And we'll show an example of that once we get into the demo. So the first main piece for like an end user to know, for example, would be item allocation keys. So you may be familiar with item allocation keys in other parts, whether you've used the old traditional way of forecasting in AX or you use these for something else. Now, they are at the core of demand forecasting. So really what those do, the demand forecast is calculated for, I'll say a stock keeping unit. And this is one thing that bothered me when Microsoft released this, is nowhere else in AX will you really ever see the terminology of SKU or stock keeping unit. Now, it's something we all probably know from our experiences, but it's not something that's really a term used in AX a lot. So what they mean here is a SKU is really an item number. So the demand forecast is calculated by default for a SKU, but you can add multiple dimensions, as we'll see later. Now, in order to use the demand forecasting tool, an item has to be in an item allocation key. And you can see here the reason for that is if you're forecasting many items, it's going to be hard to get all the algorithms and all of the background tables to work in a way that makes sense. So the item allocation key allows us to group items that have similar trends historically and really be able to forecast either at a group level or an individual item level. So you can aggregate and disaggregate as needed. And the item allocation keys allow us to do that. Now, in other parts of the system, the item allocation key percentage is really important. For example, if you're using like if you are forecasting by group rather than down at the item level, that percentage kind of splits up the total forecast number between the items. For demand forecasting, that's ignored at generation time. We're only looking at historical data. But then if you re-import the forecast at kind of the higher aggregate level later, you could reintroduce those percentages. And then the other thing that's really important is a SKU must be part of only one item allocation key if it's being forecasted, or else you'll get inconsistent data. The one thing that I found difficult when I first implemented this for a client is there's not a real good rule or way to determine which items should be placed in the item allocation key. You're probably going to have to run some reports and view some historical trends first, maybe do your own analysis before you decide what to go forward with. Otherwise, you kind of end up, it's kind of like a testing phase where you'll put items together in groups that you think make sense, run the forecast, and adjust as necessary. My hope is that in AX7 or other releases, we get some aid as to telling us, which items make the most sense in terms of grouping together. Obviously, the more testing you do, the more odd the numbers are, it lends itself to being able to make those changes. But right off the bat, sometimes it can be pretty difficult to determine which items should be grouped together. And I'll show you that when we get to the demo as well. So notes on the allocation keys just continued there. Group items that have the same seasonality trend and base values for the forecast in allocation key, because the correlations determined by the algorithm parameters in AX will really rely on that. If you have items with very different trends and they're thrown into the same group, you might get some really odd forecast numbers. The other piece is demand forecasting will generate cross-company forecasts. So you have the concept of intercompany planning groups, which you'll need to make sure your item allocation keys are associated with. If you don't want to generate the cross-company forecasts, then you can purely set a company filter at forecast generation time to say only generate a forecast for the specific company. As well as the import, you have the ability to decide which forecast you're actually importing in AX. So you could run the forecast for many groups or many companies, but then at import time actually only import either specific forecast models or specific companies, as well as apply filters. Now we get kind of to, what comes up, what is required to come up with these forecasts. And this is where it gets a little bit technical and it's tough in a high level to talk about, but these are all the out-of-the-box forecast algorithm parameters that will affect your results. And you can use some of these, you can use all of these, or you can adjust them. And it's really difficult at first glance to understand them. For example, the explanations given aren't always great for an end user to say, well, which one of these should I be using? You can really start one of two ways. You can leave the default values in there and kind of see how you get along, or you can mix and match. Now, some are easier to explain than others. For example, the forecast method, I explained that before. There are three. You would see the most commonly used one, in my experience, is ARIMA. These will all have default values populated the first time you begin using demand forecasting. You basically restore from the cube and it will populate all of these parameters for you. A maximum series value and a minimum series value, that's pretty simple as well. It would just be if you never want it to go over a maximum quantity value for demand forecasting, then you could set that here. So if you never ever would forecast past 10,000 units, you could set that. Same thing for minimum. The other things those allow you to do are in combination with some other parameters. For example, a missing value substitution. A missing value substitution basically says if you're forecasting in monthly buckets and you look back the past 12 months and in March there wasn't any data, so there's a gap there. Do you want it to substitute a value for that gap, or do you want to actually consider that a zero quantity because there was no transactional history in that period? If you want to kind of make things average out, you can see there options you have, like previous, meaning it would look at the previous historical bucket and copy the same value, mean to use an average value, or none to put anything, or a numeric constant. So you can actually allow for gaps or not allow for gaps and allow that to affect your forecast. You have some parameters that affect statistical trends they call them periodicity here. So periodicity hint would be like seasonal trends, searching for seasonal trends in the data. There's another one, auto detect periodicity. This value is actually looking at seasonal buckets almost. So for example, a value closer to 0 is going to look at smaller buckets of time. A value closer to 1 is going to look at bigger buckets of time, things like that. So it's tough. You kind of have to get used to these and see what makes the most sense. Otherwise, I'll show you a few more options once we get into AX. This next slide just explains some of those options. This is more for afterwards if you want to review the specifics on some of these parameters. We will make these slides available where you can reach out to me if you have any questions, but I don't think it's prudent really to go too in-depth on each parameter right now. So this is just an explanation of some of the more basic ones. Next, we'll have our general parameters. So when we set up demand forecasting, this is a little bit tough to see, but we'll see it when we get into AX. You set your demand forecasting unit, which I already mentioned. You link your demand forecast and your demand forecast accuracy to the cubes that have been set up. And then you also have a bunch of different options that control the behavior, performance, and accuracy of the mining model. So there's a note here that says the parameters are presented separately. So that's really what I showed prior in conjunction with this. But if you think about each one separately, then you're really going to be in trouble, because if you're using all of those parameters at once, they all affect each other. So if I were to change the value on the periodicity algorithm parameter, it's going to affect my output. Alternatively, if I changed the decision tree split, same thing. So they're really working in combination, and if I take one algorithm parameter out and leave another one, then you could have some issues. So you just really need to be aware of which ones you're using together. But what this parameters allow us to do is choose the historical trends. So the main way I like to think of this really is that if we're forecasting for finished goods, we're probably looking at only sales order demand or maybe sales order and transfer demand, whereas if we're forecasting components, we're not necessarily interested in that independent demand. We're more focused on dependent demand, like production line consumption, Kanban job consumption, maybe project consumption, because those raw materials and those components, they're not ordered on sales orders. They're ordered and consumed in other ways in the warehouse. So this general one will set up your defaults for historical trends. And then, as you can see, once we get into a couple of these next slides here, we can get a little bit more granular. So the next tab allows us to apply forecast dimensions. As I noted earlier, it will start by stock keeping unit or by item, and then you could add in more. So right now we could say we just stock by item, but maybe we also want to run a forecast for customer group. We could add in customer group as a forecast dimension, and then when it's imported into X, we're actually forecasting by customer account rather than just by all sales against the item. This is a configuration, so it's not something that really is typically changed on the fly. You could come in here and change the parameter and rerun a forecast, but that will be the parameter for everybody. So it's not like this is for a specific business unit or a specific group of items. These are the forecast dimensions that are used worldwide. So you'll need to be aware of that if you have multiple companies running forecasts, that you're either doing it at the stock keeping unit level or you're doing it at the other levels. Now, that doesn't mean you can't view forecasts by customer group or customer account. It's just what the forecast will actually apply to. If you actually bring it back into AX at the item level, aggregate for all customers, or at the customer group level, warehouse level, inventory status level, and so on. You see country, region, and state here. That's really if you're forecasting by like demographics. Some companies would like to use that as well. And then we have parameters to specific allocation keys. So in the general tab, we were able to set up defaults for historical data types as well as the parameters we would use. But in the tab for item allocation keys under parameters, we can actually say each allocation key is going to use its own individual set of parameters, because maybe my items in an allocation key in Russian legal entity are different than the type of trends or analysis I'm doing in the US. Also, if you're comparing, once again, finished goods to raw materials, your finished goods might use all of the forecast parameters. Maybe your components you do on a very basic level, or they would have different historical types that you're basing your forecast off of. So typically you're going to end up coming in your item allocation key and defining those parameters for each grouping rather than every grouping use the default ones. We also have outlier removal. So basically this is used for taking out kind of oddball orders. So for example, maybe we had one customer who called up last year and they placed one lifetime order that's not common. It really was a one-off, but it severely skewed our demand for that year or for that time bucket. We can use an outlier removal form, and it really has a very standard looking selection criteria like you would see in other reports or inquiries in AX, and we can ask it to exclude specific transactions. So for example, as you can see here, I have an item and I have a sales order number. Now, if those are entered in this outlier removal form, when I go and generate the forecast, it's going to completely ignore whatever I put in this outlier removal. So it's really useful for getting rid of basically very high peaks or very low valleys in terms of you don't want those to skew your demand. You want to take those orders out completely. Otherwise, if you don't want to take them out completely, you can manipulate the parameters to possibly smooth them. Things like your missing value substitution or your min and max levels. The good thing about the outlier removal is once you apply a filter like this and click OK, it will give you the ability to view all transactions that match that criteria filter. So you can do a double check before you apply that to your forecast to say, okay, here's the transactions I'm excluding, rather than just applying the outlier removal and hoping it picked out the right transactions. That way you're ensured you're actually taking out what you want to. After all that, after we've set our parameters, we've decided on our algorithms, we've put in any outlier removal we need to, item allocation keys are set, etc., we would want to generate the forecast. So this is done in a periodic menu from the master planning module. A couple things it allows us to do is first we set our historical horizons. That's really the date range of the historical transactions we're going to use to generate our forecast. So we're going to say for here, August of 2013 up to almost August 2014 is the baseline, and then they're starting the new forecast at 8/1. So obviously an old screenshot there, but it's basically saying this is the data we're going to use, and this is when the new forecast is going to start. We could put in filters if we wanted to only look at one intercompany planning group, one item allocation key, one warehouse, etc. We could do that. And then we also assign a forecast period. So the forecast period is basically starting from the baseline forecast start date. What are the buckets we're going to forecast in? Are they going to be weeks, months, or years? What is the forecast horizon? So how far out into the future? So in this case, I'm saying I'm forecasting in monthly buckets, and I want to forecast out a year from my start date. And then we have a freeze time fence. So the freeze time fence is allowing us to highlight a section of the forecast so that it's not changed. This is very common in purchasing, for example, where you send a forecast to a vendor and they tell you the first month or the first 2 months you can't change that because they're relying on that schedule from you to be able to plan capacity in the warehouse and plan their builds and their ships. So the freeze time fence, what it does is right now I have a value of 1. That would mean the first month of my forecast horizon is frozen. So it actually highlight in Excel to tell me I should not make any changes to that bucket because it's in the frozen time fence. It's always going to be a quantity or a value from the start date, so you can't say the 5th month is frozen. It purely is from the start how many months are in the frozen time fence so that you don't change those buckets after you've already generated the forecast. You can see here it goes out to Excel, so you have an Excel path that you use and save to. The one piece of this that's important to note is it's really best designed if you have one person doing this, which is not necessarily what happens in reality. You typically have many planners all doing their own forecasts. So a lot of times this may need to be overridden where each user is using their own file, so you're not overriding others when you generate the forecast. The issue with that is when you come to import it, it only looks at the last one generated. So I know that was something Microsoft was looking at. I don't know if they have an answer for that today, but it really was kind of like a one-user setup where you have one person generating this forecast and re-importing it. Now there could be other users, giving them data or viewing it, but it's really designed for one person to generate the forecast, bring it into Excel, and re-import it, regardless of who's going to be using that data. And that's just because of the connection to the cube and the Excel sheet. You can put comments in here, and I'll explain a lot more of this in detail once we get into the demo, which we'll be at shortly. After you generate the forecast, it will come into Excel. So you can see here a screenshot of what that would look like. It'll give you your forecast figures. It is a pivot table, so you can add and remove fields as necessary for viewing purposes, and then make changes as well. So that will be the main part of our demo, is actually showing the analysis of that data and what you can do with it. And then what's really great for managers and others is since it's in Excel, since they're standard pivot tables, you can really create whatever KPIs you need. So this one is really only comparing historical quantity to read-only historical quantity. Not terribly useful, but whatever you can do in standard Excel with a pivot, you can do here. That's the main intent of it, is using the integrated Microsoft suite of products so that you can use tools you're familiar with and not have to go outside of the system for some sort of add-on solution or build your own. You can manage your own KPIs with the data that's in Excel. And then once you have started to view it, you import these new forecasts back into AX. So the first piece is that you actually publish these to the cube. So you're publishing to the server in Excel. So you would use your OLAP tools, what if analysis, to do that. And then once it's pushed to Excel, you import those back into AX through a periodic job that could be set on a batch if you needed it to be, and it's going to look for that Excel file, which is why I said it's really best used for one person, because it's looking for the last Excel file that was ran or the last one that was published, and we'll import that one. And you can see that when you're importing it. I'll show you what I mean by that. And then lastly, before we actually get into AX, you have forecast accuracy. So out of the box, AX 2012 R3 offers two KPIs called MAD and MAPE, mean absolute deviation and mean absolute percentage error. I always have a difficult time saying these in words that make sense to people, so I decided I would just include the actual formulas for them in case they are something that's not familiar to you, or you're not familiar with a lot of statistical models. One thing Microsoft is very open about is, this was their first attempt. They know that they don't have a lot of models that you would see in other forecasting packages. They don't maybe have a lot of the out-of-the-box KPIs that you would see in other packages. But, this is the start of them trying to get a homegrown forecasting solution, and it can be, easily customized if you have someone who really knows statistical forecasting and knows the cubes well enough where you can kind of build in some extra pieces. So now we'll go into the demo, and we'll actually walk through a lot of this in AX itself. So just to start, I'll walk through some of the setups that we discussed. We have in the master planning module, you have this whole new setup section once you have a license for R3 called demand forecasting. So this is where we would set up our parameters that I showed in my slide deck. You can see here my demand forecast unit is eaches. My defaults are to include sales order demand, production line demand, transfer order demand, and transaction demand. and I'm using right now all of the time series forecasting methods that came out of the box. Alternatively, what I could have done is if you have some items that you really aren't forecasting, you're not using statistical forecasting anyway for, you really just want a very baseline type of analysis, you can instead choose copy over historical demand, which is just going to look at the previous forecast and generate a new forecast with those exact same figures that you could then manually add on to. So the way I've seen some companies use that, for example, is they really like the forecasting in AX, but they know it might take some time before they can really apply statistical models to it. Maybe they just started using AX and they just don't have the data, or you're a new company starting out and you haven't been in an ERP system, so you have no data. What some companies will do is use that historical demand copy, and let's say next year we just predict 20% across the board. Well, I would copy over last year's data and then just manually edit the figures to be, a 20% markup of the previous value, rather than having a system try to come up with some sort of statistical method. So there is still the ability to do kind of a very basic, bare bones type of forecasting if you're not comfortable with a lot of the forecasting methods or values that are applied. Here's where we assign our forecasting dimension. So you can see in my demo system, I actually have it forecasting by customer, group, and account. I'm going to take out, I can take those out for now and re-add them later. And you can see you'll get a message here. If you ever use customer, account, or group, they're always used together. So if you remove those, they'll both be removed. If I go to add them back, or if I go to add customer account back, it would automatically take customer group with it normally. And then finally, on your item allocation keys, this is where you would set up different parameters. So you can see my deallocation items, those have pretty much the exact same as my defaults, but if we go to L, I'm using all types of historical data, but I'm only using a few different parameters. Speakers, I don't have anything set up right now. T products are only using the method. They're not using any of the other strategies to slice and dice their information or skew their numbers. TVs, so far nothing is set up, and then standard is set up for sales order demand only and a copy over the historical demand. So when I generate a forecast for groups under the standard item allocation key, it's just going to copy over my last forecast data from the bucket I use. And all of those parameters, once again, they're set up beforehand. When you first use AX, you just hit restore and it restores all these values. Otherwise, as you get used to the system, as you make decisions, you would edit these values to be more in line with what you want. So for example, this is saying a value closure 1 may detect more periodicity, meaning more seasonality trends, but processing may be slower. So I could say, let's change this to 3, if that makes sense for my company, and then if it doesn't and I need to come back and fix that default, I can just hit restore in here, and it will repopulate all of my algorithm parameters along with the default values as well. And then here's where we would have our outlier removal. So you would click New to get your selection criteria, give it a name, and a description. And then once that's populated, you basically build your query to say which transactions you want to exclude from the forecast. For now, I'm not going to exclude anything, so I'll just take this out. Otherwise, you can see since I created a query there, if I were to display transactions, it's showing everything because I just backed out of that query without applying a filter. So in this case, I need to actually remove this so it doesn't exclude all the data I want to use for my demo. And then once we actually run the forecast, just very briefly, I'll show you the inventory management module where you normally set up your item allocation keys, and you have the table under periodic where you enter demand forecasts. For example, this item has a forecast. This is the table it's populating when we re-import the data. So we didn't build any new tables that hold the forecasts once the data's in there. We're still using the old tables. It's the main bit that's changed is really the generation of the forecast in the cube and bringing the ability to bring that back into AX. So I'll do a quick sample or a quick demo of this, and then I'll show you how we can manipulate some of those parameters to get different results. But we'll try to start off as basic as possible. So once everything is set up, under periodic, we have our demand forecasting option, and we have 4 menus we can choose from. So there's generating the forecast, there's importing it later, there's calculating accuracy, so we can actually compare a forecast that was in the past. So let's say we look at last year's forecast, we can compare last year's forecast to last year's actual numbers and see how accurate it was last year, as an example. And then we have a session log, which is really just showing us every time someone's done either a forecast generation, an import, or accuracy. So it's just keeping a log of all the jobs we've run, similar to standard master planning logs when an MRP run has been done. So we'll generate our statistical baseline forecast. Right now, I'm not going to apply any parameters. I'm going to kind of run it for everything. And you can see here, I'm in a demo system, so a lot of my data is fairly old. So you'll see that the data I'm looking at, the historical data, is going to be way in the past, but I'll actually have it create the forecast going forward from the beginning of February. So starting on 2/1/2016, my forecast bucket is going to be in months, and I'm going to go out 12 months, so it's going to be from 2/1 to 2016 to 2/1/2017, and I have a frozen time fence of 2. So what that means is my first 2 months cannot be changed. I don't want to edit those because I'm committing to that being my forecast. Now, it's a little bit different than other systems because really here it's more of just signifying that or highlighting that, where in other systems, you know, it would actually lock down that time frame. I could come back into February and March of 2016 in AX and change those forecasts. This is really just in the demand forecasting tool where it would tell me what that frozen horizon is. Probably more useful, like I said, for your procurement type things, agreements with vendors, perhaps, than when you're running the demand forecast for sales. If you want to transfer any manual adjustments to the demand forecast or add any comments to show up in Excel, you can do that. I just put in some examples here. Once you've put in your information, your inputs, you would click OK, and it immediately starts executing the server operation. So right now it's reaching out to the cubes and analyzing all the historical data that was in those filters that I used. And this should just take a minute. Depending on the amount of data, obviously, and the parameters you choose, it could take longer to run. So, you know, it's not typical necessarily that, you know, companies are going to look at 2-3 years worth of history to come up with just the next year's forecast. But occasionally they will. Sometimes you're more interested in more recent history. So I have a lot of data really that I had there, and you can see now it's finished. So not too long. Not a huge processing time, but obviously the more data and the more kind of obscure your parameters are, the longer it will take. It'll tell you if it's worked correctly or if there are any manual adjustments that have been found. Right now, no manual adjustments in the previous forecast. Statistical forecast has been created, so no errors, and then it allows you to open or get to the Excel file right from your session. And it will open in Excel like this. So couple things to start off. First, on the forecast information tab, it's going to give you some of the basics of, you know, what was generated. So if, say you have that generation being done on a batch job and then somebody's really coming to Excel and viewing the file later on, they can say, okay, well, this is the data it was generated on. Here was a comment someone entered. Here's my forecast buckets and my historical data trends and when the forecast starts. No filters were applied to mine, but if there were filters, if I had filtered on an intercompany planning group or an item allocation key, those would have shown up here. And then the forecast table is going to give you a lot of data. Now, right now, this looks very, very busy. The one good thing is you can adjust it since it is a standard pivot table. So right now, for example, I'm just going to tick off actual demand just to make this a little smaller, and we'll re-add it later. So what it's allowing me to do is probably the very first time you'll open it, it will only show you from the forecast start date out through the end of your forecast horizon. So what you'd want to do if you want to actually see how it came up with those figures or look at past demand is you'd want to come down in here and adjust your dates, for example. So the first time I ran this, let's say a couple days ago, this was set to date. So it showed first off individual dates, and it didn't go far enough back. So it was only showing me my future forecast and not any of my actual past history. So I had to make sure that I was including some of that previous data so I could look at the figures in the past. So right now, we set up our forecast to start in February of 2016. The reason, and hopefully you guys, this comes through well on your screen over the webinar, is the reason these two columns look different than others is because these were the 2 months that I set to be frozen in my time fence. So it really is just saying that these 2 months are frozen. Anything past that, I can manually edit if I want to. So it's going to show me my forecasted quantity, what the statistical models came up with. It's going to show me what my current AX forecast is, if there is one. And then if I want, let's say I add in actual demand, it would actually show me my actual demand in that time bucket as well. So you could toggle that on or off as needed. Otherwise, you would just leave it off. I could turn off my current AX forecast, and then if I scroll back to the left, I can view past data. So I can say in 2015, there was my forecast. If I had actual demand once again selected, it would show whatever data is in there. For 2015-14, I probably don't have much, since, like I said, this is a demo system. My forecast used dates between 2013 and 2012 and 2013, so you can see the further I go back, we're starting to see forecasts that were loaded then, as well as actual demand. So here's a good example, of the data that was being used when I generated my forecast. I set the dates to look at the 2012 demand. These are those figures it was using, and then applying the parameters and the algorithms I used to those figures to come up with, I'll just scoot back over to 2016, to come up with the figures we're seeing in the forecasted quantity here. So you're able to look at the past data and the current data and then toggle things on and off, add more information if you need to. Right now you can see I not only have the item allocation keys, but I actually have the demand and the forecast showing per item. If I wanted to look at it at an aggregate level and I wasn't really, I didn't really care too much about the breakdown per item, I could turn off display product number, and now I'm just going to look at my aggregate forecast per item allocation key. Now, if all I'm doing is toggling that on and off in the pivot table, that's not going to affect what's brought back into AX, because in AX I said I forecasted by SKU and by customer name and group, not just by item allocation key. So if I wanted to forecast by item allocation key, I would have had to edit my forecast dimensions in AX to just actually take out SKU and forecast at the more aggregate level. So this is really just toggling for view purposes. If you need a report at an aggregate versus a disaggregate level, the actual forecast and the way it's reduced in AX will be based on those dimensions you set up previously. And then after you've analyzed this data, like I said, if we're not happy with this, if this didn't make sense, we'll just try to remember a few numbers here. We'll remember 436, 199, and 1984 for these 4 groups. I'm just going to close this Excel sheet, and I'm going to save it, and now I'm going to go in and change my parameters. So I'm going to say, you know what, I'm really more interested, instead of doing it from the defaults, I'll do it from the parameters page. Let's say I'm more interested maybe in seeing what the other value came up with. So let's try ArtXP, for example. And then if I need to override that on any of these statistical models, I'll have to do that as well. So once again, we are changing configuration here, which would apply to everybody. We're not just kind of editing my session. So I've changed those parameters, and now I can run my forecast again. And what we should see when this finishes is when we open Excel, obviously those numbers should change because we've now changed our parameters. And then what I'll show you from there is how you can manually edit those and then quickly re-import them into AX before publishing or after publishing to the cube. And then with about 15 minutes left here, hopefully I can wrap that up, show that quickly. That should only take about 5 minutes, and then we can open it up for questions from the audience. Okay, so that is now finished. We didn't get any errors, which is good. I'll open my Excel file, and if we're looking, those numbers have definitely changed. So before we were using a REMA, which was great for long-term prediction. I changed to short-term prediction, and you can see that these first two went up. RM didn't change. That was actually one of the item allocation keys where I didn't change the algorithm parameters. I only did it on the first two, the D allocation items and the L products. So those quantities both went up significantly. If you remember, I had 436 for February for D allocation, and I had 199 for L products. So using the ART-XP model, which is much more suited for short-term prediction and kind of alleviating those deviations in demand over the short term, well, when I go to long-term, it has a more difficult time analyzing that data and really just ends up forecasting much higher quantities than possibly are required, because if there's fluctuations in demand over the long term, it doesn't really understand how to smooth those out. So it's kind of given us bigger buffers in the forecasted quantity. Now, just to show you what you can do as a user, let's say we did like a copy over historical demand, or we wanted to run the baseline figures the first time to see what AX come up with, but ultimately we're going to start with a forecast that we came up with using our own tools. I could actually go in and edit any of these quantities, and as you do that, you'll see I'll get a red triangle at the bottom. Anytime there's a red triangle, that means I've edited the data, which I'm sure a lot of you are familiar with if you're using pivot tables and things like that in Excel. The other cool thing about that is if I just re-add my product number, changes can be applied at the item allocation key level or at the individual item level. So you can see once I updated 1200 to the deallocation key, it actually then went and split that up between each item in that allocation key. Otherwise, I could have said this item's going to be 300, this item's going to be 320, and so on, and just really make those changes and have it update the aggregate SKU based on the individual item SKUs. So you can see now I've now made manual adjustments to all of those lines, and then I could use those if I wanted when I re-import that to AX. So let's say I was happy with all of the trends, all of the data it came up with. I would then use standard Excel tools. I'd go to Analyze, OLAP Tools, What If Analysis, and publish these changes. So you only want to do this when you're happy with the forecast and you're ready to re-import back into AX. You publish the changes. You would save that into SQL Server, close your Excel sheet, making sure you save, and then you'd come into your periodic section and import forecast. So a couple things this will do. First, you go to your details, and it's going to show you, who generated the forecast, so who saved the last file. In that case, it was me, the admin, any comments I had, what data I used, etc. Here's where I would decide which companies I'm going to import the forecast for, or forecast models. So for example, I could take out this top company. I could even take out USRT if I only wanted to import into USMF, because once again, it's generating the forecast for everybody, but it's up to me to say, if I want to apply it to everyone. Now, I could have applied a company filter when I generated the forecast as well, to only look at quantities in that company. And then in that case, I would have only been able to obviously import on that company. You can save the manual adjustments made to the baseline forecast, and you could edit possibly the import forecast period, but typically you want this to be whatever the forecast period was. This is going to default from how you generated it. So I generated it to start at 2/1/2016. I said I wanted 12 months in the future, and it populated those numbers for me. I could then click OK. It'll tell me that existing demand forecast lines starting from that date. So if there's already forecasts in there, it's going to override these and replace them. So I'd say yes. And once again, it will now reach out to the server and try to import that data into the forecast tables. And while that's running, what I'll do, since we only have about 10 minutes or so left, is hopefully I can unmute everyone and see if there's any questions out there while that's still running. Any questions from anybody in attendance?
Hello?
Okay.
Yes, I had a question.
Yep, go ahead.
For engineer to order in this what would be kind of like a best forecasting model?
I've found, like I said, I mean, the difference really between the two models AX offers are more of your time horizon. So if you're only forecasting, like a month out and you're more of like a day-to-day manage the demand, you would use the ART-XP model. Otherwise, ARIMA is the one that's most commonly used. So really the models really only apply, like I said, to kind of your horizon. As far as the... Sorry, go ahead.
And then I was going to ask, what about the mix model?
Yeah, the mixed model can be useful. It's kind of one of those things where there's not really a best practice to say when to use it or not use it, because every company is going to have such a different combination of things they need to consider that there's not probably a good way for me to tell you, yes, you should use the mixed model or next not. Most of the time it's, this is something that people start using and they have to play around with a lot before they actually start, trusting in those figures. What I've seen is a lot of times people will run it and generate the forecasts for a few months even and make adjustments to the parameters before they actually feel comfortable enough applying this, just because it is, it is very different from other forecasting packages, and there's not, at least my point from an end user, if you're not really in tune with forecasting parameters and mathematical calculations, this stuff is difficult to make changes to and understand why you should make those changes, I should say. So I wish I could give you a better answer and say, it's really easy for an engineer to order scenario to say use these parameters and this model mix versus ARIMA, but it's a little bit of a testing, feeling out process before you get there.
Okay, thank you.
You're welcome. So you can see my import is finished. It says 100 manual adjustments were imported to the forecast, and it's been imported. So if there was any failure writing that information back into AX, we would get an error message. And then what you can do is you could go back to your inventory management module, open your forecast entry form, and see, if those were imported correctly. So like D0001 was one of my items I was using. If I go into my demand forecast, I knew I had a lot of data in 2012 and 14 and so on, but I hadn't entered a forecast yet for 2016. So if I scroll through the forecast form, we should see that those new figures were applied and imported into this table. And this one seems to have a ton of data, so we'll just have to scroll all the way down until we get, here we go. We got into this year, and here we can start to see some of my forecast figures. So while I looked at it at an item or even item allocation key aggregate level when I was in Excel, I actually did re-import at the customer account level, which is why you see these broken up by customer account. And in my pivot table, I could have selected customer account to view that by customer account as well if I didn't want to view it at the aggregate level. Because typically you're going to view it in whatever level you're re-importing it at. Here, I looked at it at the item level, but I had my forecast dimensions set to apply it at the customer level. So, that's a really good feature in my opinion, is you can look at it at aggregate or disaggregate and choose how to import it. Because a lot of companies, they're going to possibly import their forecast at the aggregate level, but they still want to know, how that's sliced and diced amongst their customers, and so they can do KPIs and reporting and get demographics and stuff like that. So that's really important. And as we can see here, it re-imported all that data back into AX. And then I won't go too into detail on this one since we only have a few minutes left. But afterwards, if you need to run forecast accuracy reports, those two out-of-the-box KPIs, the mean absolute deviation and the mean absolute percentage error, that's where you can run a forecast accuracy report, which will also export data into Excel and tell you what percentage of accuracy based on MAD and MAPE algorithms are being used. And then I'll just go back into my PowerPoint here for the last point. Oop. Sorry, it seems like my my screen there got a little bit out of line. So that was our demo, and then just a few brief slides here. Let me go back one. Just some additional information for you in attendance. We do have more webinars coming up. I think I have these put in here. Sorry, I keep hitting next instead of just viewing the webinar. Next Wednesday is utilizing procurement catalogs, NAICS 2012. And then in March, we have a bunch. We have lean manufacturing, Power BI, product configurator, and process manufacturing. If you go to ebecs.com/events, as you can see here in blue, you can find links to register to any of those webinars. We also have blog posts up. There's a blog post on demand forecasting. There's a bunch on warehousing, and we'll reintroduce more, not just for AX, but for CRM, for BI, etc. So if there's any questions, feel free to go to the eBECS website. Otherwise, you could always reach out to me as well. Next steps, what you want to achieve. If you haven't worked with eBECS before, we can do an AX project audit or an AX upgrade proof of concept. And we can also do a supply chain health check. So once again, visit our website, check out those tools. If you have any questions, feel free to reach out to me directly at alensack@ebecs.com. Visit our website or and contact us via that, or work with your project manager or consultants that you're currently working with, and we can hopefully get you whatever answers you need. With that, I'll just unmute everybody one more time just to see if there's any other questions before we sign off.
I have another question.
Yep.
On forecast accuracy, is that what kind of lag is that based on? Like a lag 2, lag 4, or is it based on your frozen horizon period?
Yeah, and that's something I think they haven't really offered in terms of getting it to compare to lag 1, lag 2, etc. It's purely based on what was the actual demand of that period versus what was the forecasted quantity in that period using the mean absolute deviation and the mean absolute percentage error algorithms. So it's really just saying what was your forecast then and what was your actual demand and comparing them, applying the mean absolute deviation parameter.
But I guess so are they using the forecast that was forecasted in the prior month? Like if I'm in February,
yep.
I'm looking at January. Were they looking at the forecast for January that was forecasted in the month of January?
Yes.
And not maybe in December that I forecasted?
Right. That's correct. It would be looking at January.
And then on the item allocation key percentage, you mentioned that statistical generation ignores that and uses historical.
Yes.
How far back? So it almost seems so. It's I reference that as kind of like a mixed allocation based on history. The time period on the history, how far back is that based on, or is it just based on prior month?
Go as far back as you need it to. So as long as there's data, it's you really enter what that starting period is. So mine was 2012, 2014, but you could go back.
Oh, I see.
As far as you have data. So if you've been using AX, well, 2012 R3, obviously you might not have back past a few years, but if you've been on AX, you can go back as far as you need to.
Okay, great. Thank you.
You're welcome. Any other questions from anyone else? All right, well with that, once again, thank you everyone for taking the time today. I know it's middle of the day for a lot of us. Once again, feel free to leave any messages at ebecs.com. Otherwise, you can email me directly. Thank you, everyone.